Hi, listeners. This is the 80,000 Hours podcast, where we have unusually in-depth conversations about the world's most pressing problems and what you can do to solve them. I'm Rob Wiblin, head of research at 80,000 Hours. We were partly inspired to interview today's guest, Kelly Wanser, because of her excellent appearance on the Future of Life podcast, which aired last October. That episode does a fantastic job of explaining the case in favor of working on climate interventions, such as seeding or brightening clouds. And as we only had Kelly for 90 minutes in this episode, we didn't spend a lot of time on introductory questions. I think this episode stands on its own just fine. But if you feel a bit lost, do take a look at that episode of the Future of Life podcast. You can find a link to that in our associated blog post. The general public, I think, tends to be pretty skeptical of climate interventions, otherwise known as geoengineering. So in this episode, we spend quite a bit of time on possible objections, such as it being unlikely that we'd want to do this kind of thing anytime soon, because it's simply riskier than doing nothing. That we don't have a clear path to rolling out climate interventions in a way that isn't really dangerously politicized. And of course, the risk of a double catastrophe, where a pandemic or some other disaster means that we have to stop our climate interventions and temperatures simultaneously skyrocket. We also cover a bunch of other issues, including the many climate interventions that are already happening, which you might not be aware of, the most promising ideas in the field today, and whether people will be more accepting of climate interventions if we found a way to do them that had nothing to do with making the world a better place. Just to note that we had some technical issues with this one, and the audio on Kelly's end isn't amazing. But if you prefer, you can always go to the associated blog post and read the full transcript instead. All right, without further ado, here is Kelly Wanser. Today, I'm speaking with Kelly Wanser. In 2018, Kelly founded SilverLining, a non-profit organization that advocates research into climate interventions, such as seeding or brightening clouds, to ensure that we maintain a safe climate. And she has gone on to lead it since then. To my knowledge, it is the only non-profit focused on climate interventions anywhere in the world. Wanser is also co-founder and advisor to the University of Washington Marine Cloud Brightening Project, an effort to understand the effects of particles on clouds. She previously worked at the US National Academies of Sciences, the Ocean Conservancy, and Lawrence Livermore National Laboratory. She studied philosophy and economics at Boston University and then Oxford University. Thanks for coming on the podcast, Kelly.
Thanks very much. Is it Rob or Robert?
Rob. Yeah,
okay.
You should get right, Rob.
The American style. All right. Thanks very much, Rob. It's an honor to be on here. I'm a fan of the podcast and looking forward to the conversation.
Oh, fantastic. Yeah, I hope today to get to talk about what deliberate climate interventions are already in active use and the case for and against further research into them. But first, what are you working on at the moment and why do you think it's important?
Well, I'm the executive director of a nonprofit called SilverLining, and our focus is near-term climate risk. So we're really thinking about the climate risk in the next 30 to 40 years. And in that context, we're very concerned that society lacks sufficient options to constrain or reduce warming if we need to, as we can see the Earth system becoming more unstable. So we focus in particular on sort of immediate steps that we can take to understand ways that we might improve our options. And that includes lobbying in the United States for R&D. That includes working with parties related to the UN and how we think about healthy international cooperation and decision-making. That includes working with young climate leaders and, of course, working with researchers. And we have last year launched a research fund. So we have lots happening. And I'm open to all kinds of questions about it.
Fantastic. Okay, so we were in part inspired to interview you because of your appearance on the Future of Life podcast last October, which was a really good interview that went through a lot of material about geoengineering, or as you prefer to call it, climate interventions, slightly less loaded term, perhaps. And so we're not going to spend a lot of time, I guess, going through the basics here of why someone would want to work on this, why it's potentially important. But I do want to get through the basic case really quickly in case people aren't familiar. So I guess the reason that people might prioritize researching climate interventions, I guess, is that it's potentially really cheap to scale them up and to cool the planet a little bit, much cheaper than potentially getting rid of carbon emissions. It's as yet very underexplored and underinvested in, and it could, as you're suggesting, be applied really quickly, more quickly, say, than carbon abatement or carbon drawdown could be applied. So if things were really going awry, you could potentially roll this out quickly and try to stabilize matters. Yeah, is there anything else that I'm kind of missing in the basic case for why someone would decide to spend their career working on this as you've done?
Well, I think the nuance here is your last point, which is about the speed. And I think the thing that many people are less aware of, even in the climate space, are that the current projections, even if we do everything right, even if we make our commitments to the Paris Agreement, even if we follow the best, most optimistic IPCC pathways, we've got 2 degrees of warming baked in. And the same scientists who made those projections are telling us that that's unlikely to be safe enough. And so our best pathway currently may be too dangerous. And so that's our main issue with watching, can we understand better what kind of danger we're in? And can we protect people? Can we have some insurance policies to make sure we're protected? So that's really kind of the essence of it.
Yeah. So if really rapid warming is coming sooner, or if it's potentially coming sooner because we've misunderstood the nature of some of the feedback loops involved in climate change, so things might turn out to be substantially worse in 30 years' time than what we expected, then I guess we want to have something in our back pocket in order to try to improve things. And I guess studying these climate interventions could also be useful, even if we don't end up wanting to use them for a substantially longer period of time. So it serves both roles potentially.
Yeah, and I think one of the important things for people to think about, it's not a happy thought, but that the changes that we're seeing in the physical world, in the Arctic, there was a story out yesterday about the currents in the ocean, about the AMOC current in the atmosphere. These things are tracking to some of the worst case projections that scientists had 40 or 50 years ago. So to many scientists, we're in it. It isn't if things are going off track. They are showing the symptoms of going off track. Yeah. So it may be quite important that we have some ways to react.
Yeah, makes sense. Okay, I imagine that people are kind of thinking up possible objections that they might have to using climate interventions, and we'll get to some of those later. But first off, I wanted to explore perhaps the thing that I found most surprising when I was looking into this topic over the last couple of days, which is just the scale of existing climate interventions that we're kind of already engaged in without people being that aware of it or objecting to it. Of course, we're changing the climate by releasing greenhouse gases, but that's not the only way. So what are some of the things that people are currently doing today in order to deliberately change the climate?
Well, so in terms of, there are things happening that are both deliberate and undeliberate or inadvertent. And I'll talk about the deliberate ones, which tend to fall more into the category of efforts to address or minimize climate impacts. So as the Earth system warms, a couple of the big side effects that are causing problems for people are changes in rain and precipitation, either producing drought and problems with water or producing flooding and storm surges. And in both cases, what we have in lots of different parts of the world are efforts to disperse particles into the cloud layer, either to make rain or snow, or to induce precipitation offshore to prevent flooding. And so there's a massive rainmaking program in China in an area the size of Alaska to increase precipitation in the Tibetan Plain. If they scale that up to the size that they're expecting to, that would be a big enough sort of weather modification effort to affect atmospheric circulation and weather in other places. So you start to get into these sort of bottom-up efforts, which aren't exactly the same mechanism as what we're talking about to cool climate, but they're similar. And we actually have quite large-scale weather modification activities in the United States that most people aren't aware of. So where Huron is in Colorado, they disperse particles into the cloud layer to increase the snowpack, not just for skiing, but actually at a large enough scale to try to improve the water table. So these are the kinds of things that are escalating. And then in Indonesia, it was actually covered in the news that they had a couple of different rounds of injecting particles into clouds offshore to try to induce rain to reduce flooding. And so we anticipate that as the Earth warms and climate impacts grow, these will escalate. And then there was a very small test over the Great Barrier Reef that was really more about studying the mechanism for what you might do to increase clouds and cooling over the Great Barrier Reef to try to protect it. And so those things are starting to emerge. At the same time, we have some accidental cooling happening. So what many people aren't aware of is that the particulates in our pollution, so not the greenhouse gases, but actually the dirtier stuff that they're concerned about for breathing, that often has the effect of mixing with the cloud layer to make clouds brighter and provide some cooling. And you can see this from space in the shipping lanes as they traverse the clouds and create big streaks. And globally, scientists believe that this is causing a significant cooling effect. So we have an accidental version of the kinds of things that, our organization helps people look into this kind of cooling effect going on as well.
So we've got attempts to get precipitation in Colorado and California, I guess, in order to get water where people want it to be for agriculture and for other reasons. Seems like there's tens of thousands of people employed in China trying to generate rain and do other things to improve the weather or climate in regions that are a bit difficult. There's also United Arab Emirates is also trying to, obviously it's an extremely dry and hot place.
Oh,
and
you read our documents. Yeah. So United Arab Emirates has a $400 million fund. We don't have specific information on how successful they're being in their efforts, but they're funding a lot of R&D into trying to increase precipitation in that part of the world.
How much control do we have over the weather? It seemed like there's a lot of money being spent on trying to generate rain, and I guess either to get water where you want it to be, or to get storms to rain out before they reach places where, say, the hail is or the flooding is going to do damage. But do we know that these methods work very effectively?
So I'm not a scientist. I work with scientists, so I'll caveat by saying I can say things that they probably wouldn't say. But my understanding is that some of the highly localized efforts to precipitate rain out of the kinds of clouds that normally carry it, there are fairly predictable ways of doing that, and some fairly predictable ways of trying to increase snow depending on the conditions. It's really, really hard to make precipitation in places where the types of clouds that produce it don't ordinarily occur, like in the Middle East. That's a harder problem. And overall, as the climate warms and the weather patterns change, it's not easy to either locally manage your sort of local climate or to counter what's happening with warming. So it's a pretty hard problem. Weather prediction is a hard problem. Weather management is a really hard problem. Clouds are one of the biggest uncertainties in all of it. And they're at the center, of course, of these things. So these things are not quick and easy fixes. But they are indications that we are likely to need to have more information, better observations, better tools for trying to figure it out. Because as the problem escalates, people are going to try it, and they're likely to scale it in larger ways.
So, setting aside climate change concerns, how much do we expect all of these efforts to increase over time anyway, and potentially have some impact on the weather or climate globally?
Well, I don't think you can decouple them. I think the weather modification efforts, maybe in the Middle East, it's a little bit different. If we were looking at a continuation of kind of 20th century climate, and the Middle East was just interested in sort of improving. So maybe in terms of sort of natural human innovation, some of this would go on. But I would say that, the relatively sort of rapid escalation of investment in it and the need for it is pretty climate driven. So it's pretty hard to uncouple the two. And when it comes to water is a fundamental need, both economically and for, community well-being. So people are going to go to great lengths to figure out solutions for water. And as climate warms, those solutions just get harder and harder to find.
So people, I think, have this pretty strong intuition that whenever humans try to intervene in the environment deliberately to get some outcome that they want, that it almost always goes awry. And so they're very wary of this entire style of intervention. Are there any examples where things have kind of gone to plan, where we were like, we want to change the environment in this way, and then there weren't terrible side effects? I mean, I suppose these weather modification examples could potentially look like that if they've worked out as people hoped.
So my favorite example is actually in the United States, and it's the largest environmental program in U.S. history. It might be one of the largest in global history. So in the United States in the 20s and 30s, we had these dust storms. And so we had this environmental problem that was partly created by settlers coming through the Midwest and sort of deforesting things. And a lot of the native species were depopulated. And so the landscape was starting to desertify. So we had the Dust Bowl and the big storms. And so they launched a program called the Great Plains Shelter Belt, where they planted rows of trees, and they even sort of dotted them with squirrels and native species and things, in a sort of 200 to 300 mile strip up and down the Midwest of the United States. So almost border to border. And if you drive through sort of Nebraska and Kansas and things, you'll see these lines of trees, like your cornfields, and then just a line of trees. And it had the effect of actually helping to undesertify and change the climate conditions in the Midwest. So it was quite successful. And it was a multi-year, hundreds of thousands of people. It was partly a jobs program, but it changed the climate in the United States, or reversed the damage, if you like. So it's an interesting one. And another sort of one to think about, which isn't necessarily, I'm not trying to advocate that you do these things if you have other good options. But if you think about it like the Gulf spill in the United States, where, once the spill happened, they're looking for ways to remediate the damage. So what we have going on with climate change is, we have a massive sort of toxic spill into the atmosphere. And the immediate sort of most damaging effect of that is heat energy trapped in the system. And so the question is, do you try to do something to counter that or to abate it? And sometimes in nuclear accidents or chemical spills, they do similar kinds of things. So we're trying to think about it in terms of like counter effects to something we've already done versus, I think this isn't just, hey, we want to go take pure nature and do something to it. We're taking a highly damaged, polluted system and trying to figure out if we can counter some of the effects to keep some of the life in it stable.
All right. I think that's enough about what we're already doing today. Let's think about what we could potentially do in future in response to climate change specifically. I guess, what are the few most promising kind of climate interventions for limiting global warming that we should potentially be looking into?
So my organization, SilverLining, we follow the recommendations of the scientific community. We do some of our own review, but where scientists landed, there were a couple of assessments that asked that question. If we needed to cool the planet quickly or counter global warming quickly, what are the best options? And they looked at things from mirrors in space to, shiny objects on the ocean, to materials on the Arctic, to, things like putting particles in the stratosphere or brightening clouds. And one of those assessments was in the United Kingdom, the Royal Society, back in 2012, and then in the United States by the National Academies in 2015. And so where they landed was that the most promising approach was leveraging one of the ways that the Earth system regulates its temperature, which is the reflection of sunlight off of particles and clouds in the atmosphere. And so without getting into too much detail, but the surface-based approaches tend to be much lower in terms of effectiveness for a variety of reasons, including the fact that clouds are in the way. And they also are more invasive in terms of their potential to interfere with ecological systems. The space-based approaches were actually pretty far off of the kind of engineering that would be required because the area mass that you would need to affect sunlight coming into Earth is actually massive. So even though people think, we put lots of satellites up and things, they're talking about like 1 billion square meters out at the apex between the Earth and the sun. And so the ideas I've heard about that were sort of self-replicating robots who could mine an asteroid and then build a filter and then,
At that point, you should just leave Earth and go colonize Mars, maybe.
Pretty much. So really, when you think about the notion of slight, when they talk about increasing the reflection of sunlight from the atmosphere, they're talking about 1 or 2%. So it's a slight modulation of the way particles and clouds are reflecting sunlight in Earth terms. And so it becomes more feasible and less invasive. And then it turns out that we're doing it already in a way that we don't understand very well.
Okay, so the surface of the Earth is kind of too annoying for other beings that are there, including humans. Space is very expensive to operate in, so you want to work in the middle ground. I guess clouds are appealing because, we already know a bunch about clouds because they exist. And I suppose we know that clouds aren't a disaster because there's plenty of clouds already and it's not causing that many problems. And clouds turn out to be extremely reflective. They're very good at reflecting light back out into space. And we know methods for creating more clouds or making them brighter. Is that kind of the case for focusing on clouds?
Well, I think both the clouds, from a scientific perspective, they're recommending not just the cloud layer approach, but also the possibility of putting particles in the stratosphere, which is a different technique, which we do a little bit today in terms of air travel and things like that. But volcanoes have done it in the past. And so when Mount Pinatubo erupted in 1991, it was a big volcano, so it pushes lots of material all the way up higher than usual, reaches the stratosphere, And then once it's in the stratosphere, it tends to stay there and circulate for a year or two. And so what happened in the following year is the Earth cooled off over a half a degree Celsius. It was measurable. Arctic ice recovered. And so that volcano cooled the planet for a year or two measurably. And so the other idea is, okay, take airplanes up to the stratosphere and release particles that circulate for a longer period of time, for a year or two, and you can slightly modulate the incoming light. And so both of those ideas, scientists feel like they have a bit of a handle on because they've observed analogs to it or sort of similar things. And I think so the kind of the top recommended priorities for research are those two things, and they have different characteristics and different risks.
Yeah, what are the technical pros and cons of, I guess, cloud seeding, cloud brightening, and putting things in the stratosphere in order to try to reflect light?
So I'll start with the stratosphere. So the stratosphere, I think many scientists like because the stratosphere is uniform, so it's easier to model. And so it's easier to look at some of the first order effects of we put the materials in. There's some important studies that we have to do because we don't know the effects of these things over longer periods of time. So, but I would say advantage-wise, firstly, they feel very confident that they know how much sunlight they can reflect. And that's a big plus. And then figuring out how you get it to the stratosphere, it turns out that it's very likely that you need to put it up in the range of 20 kilometers in the atmosphere. And that's out of the range of current cargo carrying airplanes. So you might need new kind of aircraft to bring it up there. It also turns out that we today don't have a good baseline of the chemistry of the stratosphere and some of the things we need to know to figure out what to do and how to minimize the risks. So the risks of putting material into the stratosphere there's some pretty significant ones. They may be low probability, and you really want to figure out how they work. So the biggest risk that scientists are concerned about now is that it will putting material in the stratosphere, reflecting sunlight, will slightly increase heating in the stratosphere itself. And that could change the circulation of the atmosphere in ways that we don't quite understand. And so that would be one of those things that it might not be a problem or it could be a really big problem. And so that's where, if you're going to research, you really want to focus on that.
So that's worth testing.
Well, you don't want to test that experimentally. You want to do very, very small tests and have developed very, very good models. And then the other effect that people are worried about, which is probably a bit easier to figure out ultimately, is whether it would affect the ozone layer. And so you can do chemical tests and very, very small experiments to study that question. So that one is, I would say, the top contender in terms of scientists feeling like they have their arms around it. But it's also probably the bottom contender in terms of people being worried about it. So people have described that as sort of cheap and easy to do, and they're worried that maybe a billionaire would do it on their own or a rogue nation. Our sort of research has surfaced that it's actually not that easy, and we're pretty far from anyone being able to do it. So we're quite concerned, actually, that we get the research going.
Oh, I didn't realize that it was hard to do. I'd heard this story that it's so easy that one person could do it.
It's really not, partly because you can't do it with standard aircraft. And secondly, because our observation is that we haven't encountered anyone who would do it blindly. And so the other thing that you need to have global climate models, which actually only a few countries have, because you also need supercomputers to do those simulations. And then you need good observation space and ideally in the stratosphere and elsewhere. So it turns out that if you wanted to do this in any kind of reasonable way, you've really narrowed the field of who could actually do it.
Okay, what are the pros and cons of the cloud methods?
So the main con of the cloud method is they actually don't know how big the effect is. It could be quite small, which would be good news for the accidental form of it that we're doing now. It could be quite large. And so if you look at, the Intergovernmental Panel on Climate Change, who produces the big global climate reports, they have a chart and they include this, what they call cloud aerosol effect in the chart. And they have these things called uncertainty bars where they say, okay, this is what we think the effect is, and here's the uncertainty bar. It's the biggest uncertainty bar in the chart, and it's over a degree. So the main challenge with the cloud brightening effect is figuring out, can you isolate that effect? Because clouds are super complicated. There are lots of aerosols in the system, what they call aerosols, little particles. Clouds are made out of little particles forming into clouds. So it's a hard problem to kind of dissect that and figure out what the effect is and what it could be. And the team I've been working with for a long time at the University of Washington and a couple of other institutions, what they're trying to do is to say, okay, well, theoretically, the ideal particle to use for this would be little salt particles because they attract water, and you'd optimize how they work, and then you'd figure out what is the biggest effect you could get in an optimized way. But that's an open question. And so the first question you have to answer with cloud brightening is, does it produce a significant effect? And then beyond that, on the risk side, the proposal for marine cloud brightening, the idea is to take these banks of clouds that are called marine stratocumulus, which are pretty pristine and relatively thin, and they exist in like 3 different places in the ocean, and just brighten those up so they're together pushing, a couple degrees of warming away from Earth. That will create some cool zones. and so one of the questions is, what does that do to the way, circulation and weather and things like this work? And people are quite concerned about that, as they should be. So together with these very small scale experiments you want to do to figure out the local effects on clouds, you want to combine that with different scales of models to work out, okay, how does this affect the system? That particular kind of study should actually help us better understand what's going on now.
Okay, so with clouds, we're very unsure about the magnitude of the effect. I suppose, does the effect on the clouds kind of dissipate more quickly? Is it something you have to keep doing every day? I guess the stuff stays up in the stratosphere for quite some time, but...
That is a great point. So the effect on clouds is maybe multi-days to a week. And so the idea is that you would have ships continuously sort of misting the clouds as they go. So advantage is you can remove the effect quite quickly or adjust it. But the disadvantage is you have to keep doing it relatively continuously.
Yeah, it sounds a little bit more expensive if you have to keep pumping stuff up there. Although I suppose you're not pumping it up as far as the stratosphere, which I guess the stratosphere is a bit harder to work with.
I think actually that these things are expensive in sort of absolute terms, like for you and I, whether it's, $10 billion a year, $40 billion a year, relative to other things, they're so inexpensive that their sort of marginal costs across each other isn't super meaningful. Like in the United States, one big hurricane storm will cost us $80 billion. I think the fires last year ran us $180 billion. So what we're talking about in sort of U.S. terms is maybe, half an aircraft carrier or something. And I think it's still an open question as far as the operating costs of these. I think they've been quite underestimated in the, first round of literature because they just look at, we need to carry material up. And if you think about real operational running of these things where you need data and information systems and security and continuity and all these kinds of things. So it's probably running in the tens of billions a year, no matter what you do.
Yeah, but that's pretty small potatoes by global government standards.
By global government standards, but it does limit probably the amount of nations who could underwrite something like that.
Okay. So I've noticed that people don't seem to raise objections to climate intervention so long as they're unintentional. So people are worried about climate change, but not as much as they're worried about geoengineering. And maybe they have some concerns about the cloud seeding stuff that we were talking about earlier, but they don't seem nearly as worried about that as the proposals that people have for actually deliberately making things better. So I was wondering, as I was preparing for this interview, can we get these things to happen just by making them an accident? So we have to find some other reason that we want to throw salt up into the clouds, some way that's profitable, that has nothing to do with making the world a better place. And then maybe by accident, we can make the world a better place and people will accept that. Does that make sense?
I hadn't really quite thought about it that way. That's fascinating. Because oftentimes the correlation with it is pollution. And of course, they're trying to get rid of those particles from pollution. So figuring out whether you should have an ancillary benefit that people would buy into. One of the things that we ran into with marine cloud brightening, even in the research, was kind of, once the rabbit is out of the hat or the cat is out of the bag, people were sort of like, well, you have to call it geoengineering, or you have to say, at least part of what it does. So it's pretty hard to get people to to decouple that. We focused a little bit more on trying to clarify that some of these things are going on. And so that is the nut. Like, is your objection that it's intentional, or is your objection around safety?
Yeah. It's an example of a generalized phenomenon that I've noticed where if you say that your project is trying to do good, then people hold you to a very high standard and they don't tolerate negative side effects. Because like for some reason, I guess they approach it then with a moral philosophy framework. Whereas if you say, I'm just trying to make a bunch of money, then they're like, oh, well, you're not trying to do good. So they don't think about it as a like moral issue necessarily. And they'll tolerate all kinds of negative side effects that businesses have just because that's normal and something that happens all the time. There's something that's kind of funny going on.
I think I'm not sure they're all the same people. So I think the problem that we have is the people who are most concerned about the health of the environment and what have you, they're not necessarily the ones pushing things forward on profit motive, or, you know, the fact that I like to have a big SUV or whatever it is. And so when you have something that's actively trying to help the system, you can actually narrow the constituency down. And, you know, because people who are just, you know, fast fashion or living their lives or whatever are not the ones super concerned about it. I don't know. But it's a really interesting question.
What are the most common objections that you get to this whole approach? And I guess why do you think they're wrong in brief?
Well, the primary objection is related to your comment before about things that are intentional. And I think it's linked to the primary objection that we get here, is that there's a concern that this will be, you know, a pacifier for society, you know, to one more thing that says, oh, we can wait. We don't need to take action on the root problem. And the root problem is still that our atmosphere is a toxic waste dump full of greenhouse gases. And it's absolutely imperative that we bring those down as fast as we can. There isn't an intervention that solves all sides of that problem. And so there's a legitimate concern that people have that this will be another sort of delaying feature. And I think, you know, 50 years ago in the 70s and 80s, when, you know, the climate problem was early and scientists could recognize exactly where it would go if you kept going, that just turning the knob down on greenhouse gases would make eminently more sense than thinking about, you know, putting stuff up in the atmosphere. And at that time, I think it would be very reasonable for people to say, you know, why on earth would you work on that? Let's turn this down. Let's never approach where you would need to go. Now the situation is different. You know, we're driving up to the cliff's edge. We're driving up to that place that scientists never thought we would go. And so in that way, then we have to think about, is it really the case that, you know, talking about these interventions will reduce society's motivation? There were some social scientists at Harvard who actually studied this, and they felt like it could actually propel urgency. So if you think about, you have a medical condition and they tell you, we're looking at some pretty invasive treatment for that condition if it keeps progressing. That's what we're here to say. And so there are some people who think that it could actually have the opposite effect and motivate society to say, oh, the problem is really that serious.
That makes a lot of sense to me. It seems more intuitively sensible to me that talking seriously about how we're going to have to do these wild, seemingly extreme things that, well, maybe people overestimate how dangerous they are. But that's great for this purpose, because then they're thinking, wow, you're going to do this crazy, risky thing to the climate in order to offset what we're doing. We really should do something about it so that doesn't become necessary. There's something funny about this. I think it's called the moral hazard objection. People say, well, if you talk about this and explain how you can solve issues with global warming, with climate interventions, then we won't want to reduce our carbon emissions. It was such an influential argument, an incredibly influential argument. And I think it's an important consideration to have. But I'd never saw anyone kind of try to quantify how large is this effect, and is it large enough to offset the benefits of looking into it? People just kind of latched onto it and used that to shut down the debate without seriously doing any empirical analysis to see, does talking about it cause people to care less about reducing emissions? Which direction is the effect even?
Rob, you're giving me a really, really good idea for some public research. I think that's a fascinating question. It's a wonderful question because part of what we found is that some of these claims are not held to a standard of evidence, and they're almost put forward as, a self-evident or foundational assumption. And so we find ourselves, the people in the room, saying, we're questioning that assumption. And whether that is the effect it has on people, and also whether stepping forward in research increases or decreases that effect. Because the other thing, I came to this as a person who didn't know anything about it. And as I started to look into it, the more you research it, the better you understand it, the more daunting it is. And so it's much better for us to look into it. We may find out that one or more of these things we can never do. And we've had climate experts that are quite opposed to research in this area based on the moral hazard argument also say, well, if we need it later, we can just do it. And I'm here to say that we know very little, and part of what we may learn over time may actually put us off wanting to do it, or, really understanding its limitations. And so the argument against research in particular is the one we take the most issue with, because we would like to know if these things are off the table. And we would not like anyone to think we've got this thing in our back pocket that we can whip out, because we don't know that yet. And that's a moral hazard too.
Yeah, the whole moral hazard, this argument shows up again and again in different areas, and I've become more and more suspicious of it over time. I mean, like people raise this, for example, with face masks, saying, if people wear face masks, then they'll socialize more, and it will offset the benefits. People objected to
no. That's
people objected to
putting. I heard that one.
Yeah. Oh yeah. Well, I mean, that was a huge argument that people made last March. People also objected at the time when seatbelts were becoming mandatory, saying that if people wear seatbelts, then they'll drive more recklessly and this will offset the safety benefit. And I mean, it sounds crazy to us now, but this was an argument that people really took seriously, this kind of offsetting behavior, moral hazard issue. It's too general an argument. And I think it doesn't have a strong track record empirically of panning out that, in fact, these offsetting effects are especially large. And I mean, even sometimes if you wear face masks and that allows you to socialize more and say that offsets all of the benefit of the face mask, people like to socialize. So people never consider that kind of that benefit that people are getting. It's like, if all else equal on safety, maybe you'd like to have people be able to meet one another. But yeah, I think in general, I would advise people having a red flag when they hear these kind of arguments, especially if there's no attempt to quantify the magnitude of the effect. It's suspicious.
And for people who care about climate change in particular, this same arc was present for early discussions about adaptation research. And so I come from the tech industry originally. I came into climate later, and I was learning about some of the history of the discussions around things like adaptation, where there was this strong objection from within the climate and environmental community for research and adaptation because they thought it would create this moral hazard. And so research was really dampened for a decade or two. It's only been in the past few years where you have active funding for adaptation research. Now imagine, because my background is economics, and I'm thinking the best way to motivate people would be adaptation research, because this is not very adaptable. And so the more you're looking into the costs and the damage and the things the backflips you would try to do to adjust, the better a case you would have for, the kinds of actions that they want people to take now. So to me, that's one example of, this moral hazard argument playing out in the opposite fashion as to what was intended, in kind of a really irrational way. It was pretty damaging to society. We're not ready to adapt, and we don't understand what the costs of these things really are.
Yeah, I mean, you can object to some carbon mitigation strategies on the same basis as well. Say, figuring out how to make concrete more environmentally friendly means that we're not going to do enough to focus on solar. Almost anything can cause something else to seem somewhat less important if it has substitutability. But yeah. Anyway, that's an argument that we're not super convinced by, either of us. But what do you personally think is the best reason not to fund more research into climate interventions? I'm keen to kind of steelman the arguments against and see what's the best case we can make.
I think it depends a little bit on where you're coming from. As a philosophy, economics double major back in the day, and so there's a lot of applied philosophy here. If you're coming from first principles, there are some people who object to this on a more principled level. Some are like the sort of basic, it's playing God. It's not a place that humans should go, similar to some of like the genetic modification arguments. But the other one, which is a little bit trickier, is there's a strong objection based on the fact that these things are not collective, they're inherently centralized. It's a centralized function for influencing what the climate does, which means that it's often perceived to be disempowering and something that could increase the disparities in power and decision making. So wealthy countries, technologically advanced parties will now be able to manipulate the climate. They might be able to do it in ways that advantage themselves versus other people. And there's no decision-making structure that you could conceive of that would solve the problem of that. And I get that a lot. And I get that from sophisticated people.
That does sound like a kind of plausible argument. I suppose I haven't thought about it for very long, but it would be somewhat concerning. I guess people have made the other argument that because it's sufficiently cheap, more places could do this than can do a lot of other things. So potentially you could get different countries trying to compete to have different effects on the climate in order to get the outcome that they want. And that would be like an alternative bad scenario, perhaps, where there's like everyone's doing it and pushing in different directions versus the other one where it's centralized and the most powerful group takes what they want.
Well, the argument for everyone pushing and doing it in different directions, we're starting to see hints of that, maybe not at the global level. To us, that increases the case for research. And our argument is always about the research, the R&D. And then let's use information, let's use science, let's do science-based decision-making. Similar to COVID, let's have a vaccine track, let's have a mask track, let's have a tracing track, and let's make science-based decisions about what combinations of things are going to keep that curve from, going hockey stick on us. And so for us, the arguments against research are almost always, we're going to say those are weak, because at the end of the day, we don't buy the premise that people can't handle information and we need to paternalistically keep it from them.
It's a suspicious style of argument to say that knowing more about this would be dangerous. I guess sometimes that's the case, but typically we assume it's not.
So our solution to the equitable decision-making problem is scientific cooperation, is let's open access to information. So for example, at SilverLining, we fund researchers in the global south. We have a global youth initiative. We're working with Amazon to put climate models and these simulations on the cloud so people all over the world can access the information. So the first step is, can we get people access to information? Then the second step is, can you create a structure for cooperative decision-making? Because this is very much a win-win, lose-lose. Like a warming planet has very few winners, and a stable planet has mostly winners. So we're more optimistic than pessimistic that we think it's possible that people could come to agree, especially if they have good information about what's going on. And our example for that is the Montreal Protocol, which is the most successful sort of environmental cooperation in history to preserve the health of the ozone layer. And every country in the world is signed on to that. It's still managed through their scientific assessment panel. And so, we're making a bet that, an evidence-based approach that's focused on the real safety situation in the climate system is one that people could come to agree on.
Okay, I'll put to you a different argument against doing research. I suppose it's
right,
very easy to come up with.
Argue against. I apologize.
Yeah, sorry. let me have a go.
I'll be more compliant.
It's easy to come up with arguments not to actually do climate interventions, because there's all sorts of problems that they create. It's like it's a harder argument to make that we shouldn't even find out what those consequences would be. So it would be somewhat surprising if that were true, but maybe it is. Anyway, yeah, one of the better arguments that I saw when I was preparing for this is John Halstead, who I think works at Founders Pledge. He's become something of an expert in climate change interventions, or how to give to in order to influence climate change, and we'll stick up a link to some of his work. He used to be more in favor of doing research into climate interventions. He became a bit cooler on it when he realized that in his mind, he doesn't think that we're going to want to use any of these climate interventions for like 30, 40, 50 years probably, because he thinks even though climate change is risky, these things will seem more risky and more damaging to international relations for at least until climate change reaches, say, 3 or 4 degrees of warming. So that's like one of his premises. And then he says, it seems like we could figure out how to do these things in about 10 years if we were really trying. So we could plausibly start in 20 or 30 years' time. And that would have the benefit that we haven't produced this knowledge that's going to be sitting around in the meantime that could cause people to use it when it shouldn't be used, or potentially could allow it to be kind of weaponized, or maybe we'll find out something about the climate, about how we could destabilize it that would allow someone who had negative intentions to use it. So it's like, maybe he wants to look into it, but like later down the line. So we find out this potentially dangerous information at the point where we really need it. What do you make of that?
Well, it has a little bit of that flavor of back pocket argument. We can pull it out later. But mostly, I think the big problem that we have with it, other than it being paternalistic, is that there's a lot of suffering baked into that approach. So conservatively, 1 billion people are predicted to be displaced in that time period that he's talking about. The island of Tonga, they have evacuation plans. In that time period, their home will no longer be there. So one of the questions is, maybe for we in Western countries who have some resilience and ability to adapt to, certainly in the United States, we're not adapting that well. But the issue is, do we have a responsibility to explore for people who currently are projected to face a lot of catastrophe in that period? So one of the ways I think about it is, let's hear from those people who are kind of at the front lines of climate change, because it's happening now. Cape Town ran out of water. And from here to 2030, they are predicted to run out of water more and more frequently. And that may or may not be a livable situation. And so I think that what we have to look at closely is the reality of the loss of life, the amount of suffering, the loss of home, and real catastrophic damage, and whether we're willing to say, okay, we're going to write that off, or we can do better. I'd like to at least explore whether for those 1 billion people we can do better. And most of the people that we're talking about in that billion, they didn't cause this. They didn't cause this. So you have somebody coming from the places in the world that did, saying it's okay to wait. So when we talk to people from these regions and we explain, they tell us what's happening in their region and what they're concerned about, and we talk about these things, many people are very interested that they get explored, because for them, it's existential.
Yeah, it seems like the crux that we'd want to look into, if we wanted to go into this more, the crux seems to be an empirical question of, is it plausibly wise to use climate interventions in 10 or 20 years' time, where John is kind of leaning against, and you're thinking, well, no, maybe there are scenarios where it would be important to use relatively soon. In order to kind of resolve that, it seems like people are more concerned perhaps about the situations where you put sulfates into the upper stratosphere, because they affect the entire world, and it could have effects like all over the place in ways you didn't intend, in ways that some people object to. If you're doing something like just seeding clouds around Cape Town in order to deal with a drought, and then if you stop seeding the clouds, then they stop appearing because it's like a relatively short-term effect. It seems like that could potentially be a lot safer. And I wonder, how much can we muddle through trying to cool down the planet just by having like each country try to tinker with its own local temperature in order to get the temperature that it likes and the level of rain that it likes?
Well, I think it's a great question. It goes back to our conversation earlier. Certainly people are going to try. But as the earth warms, it becomes harder and harder to counter those effects. Kind of like it becomes harder and harder to build seawalls that can protect London. It depends on how far you let the problem go. And so the problem in not addressing global warming and trying to sort of shift the effects around is that, the kettle is sort of boiling underneath you. And so it's the same with trying to do sort of localized things to try to cool the Arctic. The problem is the whole system around it, which is highly interconnected, is continuing to warm and push energy around. So you may be able to do things in the short term, but if the system continues to warm, it's very unlikely that you can sort of outrun it with those techniques. Now, if you're talking about, well, everybody starts to brighten clouds and spots and then it all sort of aggregates, that would be pretty interesting too.
Yeah, I guess so the normal plan is to do this over the ocean, so it doesn't affect, I guess it's like further away from people and maybe the right clouds are there. Whereas this would be an opposite approach of like doing it around cities and people because they like it.
The problem with doing it around cities and people is it's already happening. So that's the stuff that the pollution that's rising from cities. There were 2 big accidental experiments in this that happened last year. So we push all these pollutants up, and part of what they do is brighten clouds. They mix with clouds and brighten clouds from coal plants, from ships, all of that. So during COVID, when the pollution came down, you had, especially around cities, all that pollution go away. So people are trying to study that. So effectively, sort of cities and ocean ships are doing it now, but we don't have a good handle on how effectively they're cooling. And there are lots of drivers to bring out those particles because those are the same ones that affect people's health. So the second experiment that happened was in January of last year. They implemented emissions controls on ships. And so they're ratcheting down those particulates from ships by 85%. And so they're also studying, okay, what does that mean? We'll have less brighter clouds over the ocean potentially.
People might be a bit surprised that we don't already know more about what these things would do to the climate. But something you said in another interview that I was really surprised by was I think the entire US budget for all research into kind of climate change and modeling weather and climate is like $2 billion, which is like, a large amount by the standards of one person, but by the standards of a country and by the standards of scientific research is really a pittance. And that helps to explain why we can't look into all of these questions about the interrelations between all these different like sub-factors of climate and weather.
So you're absolutely right. I mean, the total level of research investment in the federal government in the U.S. is about $2.6 billion, which compared to other things is just irrationally small and compared to the magnitude of the problem. And so for questions like this, you'd like to think that, countries like the United States or places like Europe would be flying planes and funding studies and really drilling in on this question, because that question also has to do with even the local prediction of weather and how valuable that is. So it's one of the really eye-opening things when we got into this work was looking at the sort of state of our global ability to kind of monitor and predict climate and the level of investment we have. So one of the best things we can do is immediately start to invest in that so we get a better handle on what's going on.
Yeah, it seems like it would be justified even setting aside climate change just because the enormous economic value we get from being able to predict the weather more effectively. I wonder, even without doing a whole lot of experiments, it seems like there might be just a lot of evidence kind of lying about if someone has a look at it from these natural experiments where pollution goes up and down for this reason or that. Planes change their route and we can see what effect those particles have and then when it warms here, like what effect does that have elsewhere? There might be some low-hanging fruit here.
I like that expression. There might be opportunities lying about. I think there certainly are. And particularly with these natural experiments, I mean, it's just the onus is on us to actually wring everything we can learn out of them. For these particular climate interventions, there are some really important, very small scale, what they call process studies that you want to do, because in addition to these kind of natural and accidental experiments, one of the things they're trying to do with climate intervention is to say, can I do it less invasively and more cleanly? So I'm trying to figure out, can I do a better job than, the dirty particles from volcanoes or the dirty particles from soot? And so these little process studies where they want to go, puff a few clouds over the ocean with tiny salt mist, or they want to go up in the stratosphere and do some releases so they can follow the chemistry and the evolution of the particles. Those are pretty important if you want to figure out like downstream, what are the risks of this stuff and can we moderate them? So you still need those, and those are quite important.
Let's do one more objection, which I think should be taken seriously, which is that we don't really have a clear path to rolling this out in a way that isn't super politicized and leads to conflict and frustration between different countries. Like you mentioned the Montreal Protocol, which was a very effective, really flagship attempt to get global cooperation to protect the ozone layer and has done a very good job. But then there's other areas in international coordination where it seems like we really struggle to get people to agree on anything. I think in 2019, some countries brought to the UN that they would like to do more research into climate interventions, and they couldn't even agree to commission a report to look into it. So sometimes we really struggle. And you wonder if one country, China wants to go ahead, but India gets really annoyed. Maybe there just isn't really a way to get agreement on this in a way that would make it safe.
Well, we actually objected to that proposal in the UN because it wasn't one of the forums where they can really look at the science. And so we do think that how matters. And the most successful areas of environmental cooperation, even other areas of cooperation like the Ballistic Missile Treaty, the ones that are very science, evidence, and data focused have a track record of being most successful. And the ones where the sort of politics rules or philosophy rules or are are less equipped to do rigorous science and to follow that, they tend to be a lot less successful. And so even the IPCC is somewhere in between, right? But the Montreal Protocol, rigorously science focused, they follow the evidence on what's happening to the ozone layer. And so I think, we really think, and again, I'll start by saying, because sometimes I find myself in a fundamental argument between pessimism and optimism, and between defeatists, it's impossible. And we will not proceed on the basis that something is impossible. That's not a concession we will make. Yeah. So we will say that, as climate change progresses and looking at these things, we step forward on the basis of what are the most successful examples of things that are really hard getting done. But if the world can agree not to set off nuclear weapons, which they have so far since World War II, I'm not sure this is a harder problem in terms of, managing what we need to do here.
It's a very interesting model you've got there, where I guess you're saying if the discussion all becomes about philosophy and ethics and I guess humanities, things where people kind of naturally disagree and can talk forever, then maybe that just leads to lots of disagreement. But if you can bring all of the engineering, technical, scientific information to the table and get everyone focused on that, then maybe that would unlock some agreement, because people would see things that could be done that would be mutually beneficial, or at least like don't trouble people very much. But if you're super uncertain about the consequences, then it's very likely that someone is gonna raise an objection. So perhaps like focusing on the science brings a little bit more clarity.
I think that's a really good point. And it just sort of grounds the conversation into where the real issues are. So we tend to be a bit optimistic on that front. But we also, I find myself having to be very straightforward about what we're solving for, because not everybody's solving for the same thing. So we are solving for minimizing loss of life, human suffering, and keeping natural systems stable. And so we're very concerned about evidence related to that, projections related to that, and where those thresholds are that we shouldn't cross. Not everybody is solving for that. And some people are solving for the world to make decisions in a certain way. Some people are solving as a priority for other kinds of economic or disparity objectives. And we care about those things, but we're very focused on, people can't make decisions if they're not alive. And so, so we're willing to be very overt that that's what we're solving for. And then how do we get information about that? How do we rigorously assess options about that?
Another concern that people raise is the potential that doing research into this could lead people to find kind of malicious uses or ways that you could do a lot of damage or used climate interventions as a weapon. When I was preparing, I was surprised to learn that there already is a convention that prohibits changing weather or climate for the purposes of war or for conflict. I think that was because the US used that method during the Vietnam War. Yeah, how much do you worry that looking into this is going to accidentally end up being weapons technology?
Because it's a very hard problem to predict what these things are going to do, and they're not super defensible. They're slow, they're linear, they're out there. They're really not good weapons. I mean, very hard to target. That doesn't mean that countries, including the United States, might not follow that trajectory, at least from a defensive point of view. But I'm much more worried about the autonomous hypersonic weapon systems that they're developing now. In 10 years, maybe you get closer to figuring out how to target something. But even when you do, you've got a bunch of, airplanes full of particles of sitting ducks out there. So I'm a little bit pessimistic that it's a particularly great weapon. Doesn't mean people won't study it, and doesn't mean that it couldn't downstream go there. But I think that the more serious short-term concern is that people are trying to use it to adapt their own environment, and it has effects on the people around them.
Yeah, I think I'm with you on this one. It seems like it's not a very good weapon, and we already have nuclear weapons. We already have biological weapons, things that are probably far worse and far more potentially effective for someone than this. So it seems a little bit far-fetched that a state would end up wanting to do this. I guess if we found some incredibly cheap way to really mess up the climate, then you could end up having some terrorist group or some people who are really nuts try to do it. But I think the odds of finding that isn't super high. And of course, you can just stop them as we try to stop any other criminals. Fingers crossed anyway. What about the possibility that we have a kind of pandemic or nuclear war, and then this means that suddenly we have to stop doing the climate interventions that we've been using to hold down the temperature? And so we not only have a pandemic, but now the temperature skyrockets by 2 degrees because we've suddenly stopped seeding all of these clouds. And then that kind of like finishes us off.
Yeah, I mean, that idea was raised, I think, early on. And one of the things that scientists do early in these kinds of ideas is look at boundary conditions. Like, what if you did the most you could do? What if you did the dumbest thing you could do? So one of the, like, if we were to do something really dumb and just turn it off abruptly with no plan, what would that look like? And that would be bad. It's hard to conceive of circumstances where that happens. Nuclear war might be one of them, but then we're kind of on a humanity auto-destruct. So I'm not really clear that this particular thing is, if we're in a circumstance where no country on earth can maintain sending up, a few planes a month to the stratosphere, then, that level of catastrophic is probably, I don't know what to say.
Yeah.
But I generally, I'm less impressed by the cessation shock or termination shock idea as a concern, because it would be it's just a very easy thing to manage. And so it would take a very extreme circumstance for someone to do that, and all of the countries of the world to do that.
Yeah, it seems like something you would want to build into the plan is how do we have continuity of operation? So even if there is a terrible pandemic, say, we can continue to like release the thing from New Zealand or some other place that's likely to be most likely to be protected. And how do we like build up enough stockpiles? It's maybe an operations issue. I guess now that I think about it, with the nuclear war is maybe not an example, because usually there we're worried about nuclear winter. So presumably we probably don't also want to be releasing our own coolants. It might be good to turn that off.
Right. That's actually an interesting point.
So maybe it's like a really bad pandemic that stops supply chains. Maybe that's the thing that we got to worry about the most. What is just a really cool technology in this area? Not necessarily the best, or not necessarily something you want to be applied, but is there anything that you're like, well, that is just so awesome? This
isn't quite the climate engineering per se, but I just thought it was so cool, and I hope that it pans out so that we get to work with it. We were referred to a company that's doing blimps, potentially for climate monitoring, and also potentially for aerial wireless networks. And I don't know about you, but I haven't seen a blimp in a really long time. And so I was like, oh, a blimp network, that sounds so beautiful, as a way of monitoring the climate system. And so if there's anything we have to do with it, if we can have a little, blimp network up there that's helping keep things on track, I think that would be wonderful.
The technology of the future is zeppelins.
Isn't that sad?
Unexpected.
Right.
Yeah, not non-flammable helium.
Right. Well, it's not helium, so that's the interesting thing. You asked me what it is, and I can't remember.
Okay, yeah. Hopefully,
bringing it back is that they've improved on that helium situation.
So the weather often harms people, but currently, because people don't perceive themselves as having much control over it, they're just like, it's an act of God. I just have to accept that my crop was destroyed or something. But once we start tinkering with the weather too much, someone's blameworthy potentially for the weather being bad. What are the issues around legal liability if you start, seeding clouds or doing something and then someone perceives it as harming them? Maybe it didn't, because the weather does all kinds of harm anyway. Can they sue you?
Well, I think these are questions that people started to look at. The problem of attributing, like, specifically what's happening in climate or weather modification, it's a pretty hard thing to do. And it has been a problem. There's a famous case in the UK where they did some weather modification experiments like 200 kilometers away. And I think there was a lawsuit, even though it was very unlikely to have affected the relevant town. So I do think that it's a problem we're thinking about for the level of kind of responding to global crisis in a globally cooperative environment. People have proposed kind of, collective compensation structures where the people who are still subject to extremes there might be a structure to compensate that. So you don't have to be able to say whether it was caused by this if you have a sort of insurance scheme where people get compensated if they're in the, small percentage that don't come out as well. And in that model, you're just really looking at the rate of extremes, because what happens in climate is the extremes just keep getting bigger and bigger. And ideally with climate intervention, you're narrowing those extremes or reducing them back down. And so then you can look at who in the world is still getting higher levels of extremes.
Let's move on a little bit and talk about, I guess, career advice and what SilverLining does. Yeah. Are you hiring at the moment and kind of you want more research into this?
Well, yes, we are looking for talented people, particularly people who are interested in communications, senior communications people, and also legislative in the U.S. So please feel free to reach in. We are silverlining.ngo, and we fund research as well. So that for senior research teams, most of the research teams we fund are quite senior in the areas of climate and atmospheric science. But for people thinking about moving into kind of the climate arena, climate response arena, I come from the technology sector myself. And I think there are interesting opportunities for people to apply their skills from other sectors into what has been a highly academic area. So I encourage people to do that. It's not an easy thing to get into because there's a lot of subject matter knowledge, but there's some benefits, I think, to be gained by people crossing over.
I guess SilverLining is in a slightly difficult spot because it's the only nonprofit that I'm aware of in this kind of potentially very large area. There's lots of different approaches that you could take, and it might be a little bit hard, I suppose, to focus on exactly like what is your theory of change, like what is the model by which SilverLining changes things. Are you kind of currently in an experimental phase where you try to explore different options and figure out what works? Yeah, how do you decide in your strategy as an organization, and what is it?
So we're quite strategic, and I have a background in corporate strategy consulting myself. And we think about what are the levers on the system to move this forward. And the things we're trying to move forward are research and development so that we can understand the questions of what options do we have and how can we evaluate their safety against what the climate system is doing. So how do we move R&D forward in government sectors, which fund most climate research, whether there are any private sources of R&D funding, and then how do we activate like centers of excellence to get that R&D moving? We've been quite successful in that. We've only been operating a couple of years, but we got funding in 2 government agencies in the United States, starting to roll forward. Since we started, the number of programs in the United States has gone from maybe 2 or 3 universities to maybe 12 or 15, including national labs. And so it's kind of how do you get the system moving? Because these are questions about climate are very multifaceted. So these are not simple things. They involve lots of different kinds of people. And then if we're going to make decisions about them, these are going to be governmental decisions. And they're going to need to be different in the United States, different science agencies, and different people informed and involved. So we're very strategic about that in terms of how we have approached working through the US government system and the research sector in the United States, and then how we can tag into other parts of the world and start to activate research cooperation, research funding, and pathways for decision making. So we started out focused on the US and doing a lot of lobbying work. We also were trying to work with philanthropists and high net worth folks to see if there was private funding for research. It turned out that the government work went faster. And so we've gotten some private funding for research, but when people say, billionaires are going to do this, I'm like, that's not the evidence that we're seeing. And so we work with the philanthropic community, and of course we work a lot with the research community and the academic community around this. And we view these things as, it's been helpful for me coming from my background as a tech entrepreneur, because it's very similar to bringing a new technology out into the market. And I was in IT infrastructure where the technologies are sort of complicated and obtuse. And when you start out, they can seem very, to the people operating in the space, very radical or very strange or very tinfoil hat even. And then you get your early adopters, and then you start to move it out into a wider audience. And so some of that background is really helpful. And you're dealing with different kinds of people. You're dealing with engineers, you're dealing with members of the public, you're sometimes dealing with government. So our theory of change has been, can we first work closely with some experts and what we call practitioners, people from the State Department, people from the UN, to develop a theory of what would be a healthy way for this to move ahead, and then figure out what are the steps are to move that forward in a healthy way. And so that's what we've been doing. And then later on, we sort of layer on more communications and try to see if we can, if we can make sense of this with a broader audience of people.
Yeah. How hard was it to get this off the ground and begin having influence, it sounds like, on politicians and research scientists? given the controversy that has kind of existed. It's been a somewhat controversial area for several decades, and you've just thrown yourself into it.
Wasn't easy. So I actually started as, and this might be interesting to your type of audience, as a sort of passion effort like 12 or 13 years ago. And I had been on the side kind of seeing if I could help coordinate some of the scientists, especially around marine cloud brightening, where there might be money to move into the sector. So I was around the space for a really long time and building relationships with the key researchers and others in it. And so, on that time horizon, it's been very slow and relatively hard. And it's a highly academic space, and I don't have a PhD. So it was also hard to gain acceptance in certain circles that you have the standing to work on a problem like this. And that was different than tech, which is a little bit more sort of merit-based and understanding the different flavors of people. So that was a pretty heavy lift, I would say. And I'll say that to the audience if you're coming, into the climate space, because it is academic. It can be harder to be recognized if you're a person that's, say, really amazing at communications or even an executive, but you don't have the academic credentials that people are used to.
Did you find any way to overcome that, I guess, obsession with kind of prestige and eminence and credentials?
The two ways I found to overcome it. So some of the most senior people in the system sometimes are the ones who are best able to recognize, from the merits of your argument and the way you're going about things. And so I was able to develop relationships with, members of Congress, people in government agencies, people in quite senior places, who were like-minded and sort of understood a sort of executive type approach. But the second thing really, and the only thing really, is to actually make the progress. So it gets easier every year as we have, achievements in Congress, in the research fund and other things where people see the evidence of how this is working. The final thing I'll say in terms of, the difference between things that are facing the sort of academic and climate community and everyone else, like Congress and business people and tech, the way we talk about the problem has helped a lot. And so in not talking about, geoengineering and some of the classic kind of tropes, and saying, look, the fundamental problem is the safety problem. And it's about people, and it's about these natural systems on the brink. And we're talking about interventions to try to help. In the policy sector, that resonates across parties, across different kinds of people. So that's been very helpful too. And a lot of people coming from business backgrounds or tech backgrounds will have an advantage in, maybe being less academic or less conditioned in how they talk about these things.
Yeah, it's very interesting to me that it sounds like you've kind of had the most success in the policy and government area, which is perhaps stereotypically a bit more slow moving and very risk averse, and very controversy averse. Whereas maybe with scientists and with business people, perhaps it's a bit more challenging. Is that right? I guess you're maybe focusing a bit more in government because that's where you've had the best reception?
I think so. I think that I still don't know that I can entirely explain why that is, except that we found, and so far it's carried across both Democrats and Republicans, we found a way to talk about climate and the climate problem that can resonate and then also speaks to what policymakers are concerned about, which is, what happens to their communities, what do they need to know. But that was a surprise to me too, I would have to say. I do want to say, because I don't want to downplay our donors, because we have some, visionary donors, most of them come from tech. And the people who are best able to see, this kind of both approach to trying to make societal change and this kind of approach to climate have tended to be people from tech who think about complex systems and, who sort of understood the risk problem quickly. And so we have had some good success with those kinds of people. And they're terrific. Some of our donors are terrific people from tech. But no one's in a position to say, okay, I know what to do, and now I'm going to engineer the planet. or and at $40 or $50 billion a year, there aren't very many who could. So,
yeah. How much do you think kind of foolish early marketing decisions around, I guess, so-called geoengineering set back the discipline? I guess I don't know how this was presented in the 80s or 90s when it first came up, but did people kind of want to make it sound exciting and edgy, and they wanted to maybe wind people up a little bit, and did that then make it a bit more difficult to get acceptance?
It reminds me so much of tech. where, a lot of new technologies are invented by engineers and they come up with a name and they're really proud of it. And it's all reasonably well-meaning. And the term geoengineering had a certain resonance, although the original term comes from like geoexcavation, which makes more sense. And so, but it just happens, that the first couple of guys, and they were all guys, back early on, use that term. And then that's what's in the literature. And then going forward, this was a very male-dominated space up until the past 5 years or so. And now there's an enormous number of women in it, surprisingly. But, so you had that just a little bit of sort of a tech bro way of talking about it, and not a lack of exposure or a non-sensitivity to, how these things might resonate. So I don't think anyone meant to try to sensationalize it. But even when people say things like it's cheap and easy to do, that's just, that has been super unhelpful. And it turns out just to be not terribly true.
Neither true nor persuasive is not ideal. So people weren't going out of their way. It's just that maybe this required an extra special sensitivity to understand the people who would object and then try to see off those objections in the way that you spoke about it. And that's something that didn't happen.
Well, and I also think there's been a trend among scientists and climate scientists in particular to try to modulate what they're saying based on how they think people will react. And I've really spent a lot of time trying to get them not to do that. And because in addition to the fact that I don't think it's a healthy thing to do, they don't usually have good instincts about it either. And so you might think that saying it's cheap and easy to do is helpful, when in reality, it's the opposite of helpful. And what you should really be doing is just, steering straight up the middle and trying to impart information.
Yeah, I guess that's also best for credibility in the long term as well, to not try to spin and not try to market. Yeah. What are kind of the top labs in this area that people might want to track if they're interested in the natural sciences aspect of this problem?
Yeah, so I would say there are different classes of research, but one of the big classes is the climate modeling and the sort of simulation and forecasting efforts. And so a couple of key places for that are the National Center for Atmospheric Research in the United States and the Pacific Northwest National Lab, which is in Washington in the United States. But there are also arguably what many people think is the top climate model in the world is at the UK Met Office, the Hadley Center. And they have senior experts there who've worked on this problem, and others in the UK. And then in France, I believe it's at the Sorbonne, where they run a program called GeoMep, which does modeling and a comparison across the different models that have looked at these kind of questions. So those are some of the big places where they have interdisciplinary programs that are also looking at things like experiments, a bit of social science. So there's a program at Harvard University, which has been trying to launch a balloon experiment into the stratosphere, and a program at the University of Washington where they're building technology to spray some clouds. Then more recently in the United States, the federal agency NOAA has gotten funding, and they've started to fund research. And one of their labs in Boulder, the Earth System Research Lab and their Chemical Sciences Division, they're doing a lot of the background studies and some of the critical questions around the risks of these things.
So it's kind of a small area. Are there any conferences or like ways that people can get connected and looped in with the people who are leading this area if they're, curious about potentially pursuing a career in it?
It's an interesting question that you ask, because I've just been talking to some other folks about collaborating on this, because there isn't sort of a global conference. The area up until now has been so small that there have been these sort of relatively small invitational conferences, one of which was scheduled for this year and is canceled, called the CAC. I think it's a Climate Engineering Conference, but it's really only 300 or 400 people. And there's an even smaller one called the Gordon Conference, which is really exclusive to scientists, about 100 people. And that, I think, will happen in 2022. So I was talking with our partners at Colorado State about the possibility of holding an international event, possibly there or elsewhere, because there isn't one. And so we may see that, because there's lots more interest starting all around the world, including in Europe. So we may, I may put this out there and people may fire back with different things. And there are different academic meetings going on, but nothing at the level of a sort of a conference.
I guess so. It sounds like you're open to having people potentially contact you or contact SilverLining if they're interested in getting leads and learning more.
I think so. Yeah, we prefer people, who have a very serious interest because we're busy, and people who have some useful skills or want to get connected in the science or the engineering or the communications or the government work.
Yeah, speaking of skills, are there any kind of particular undergrad degrees or PhDs that people should be interested in doing if this is an area that they want to work in, or is it just so interdisciplinary that you can kind of imagine someone having almost any background, and as long as they have some useful skills, they can potentially contribute?
Well, I'd be a hypocrite if I said you needed specific certain things, because my degree is economics and philosophy with a minor in physics. There's certainly a vector in from the natural sciences. And the Earth system is a big and varied system. So there are lots of applicable natural sciences, but the closest ones to these things are climate and atmospheric science. And so if you're really interested specifically in cooling from the atmosphere, atmospheric science, climate science, cloud aerosol science, but there are different angles on looking at the impacts of that and where it goes. There's the engineering side, which is aerosol engineering, systems engineering, global systems, and some fun and interesting possibilities there. And then there's the sort of science policy and engagement side of things, which is, the tough challenge of how do you communicate this? What are the right policies and specific things that you're trying to achieve through different government and intergovernmental areas? And so from there, like I have in my team a young woman who's a master's student in science policy at The Hague. And so that's a wonderful, there are some science policy programs that are really strong. And if you're interested, that's probably an interesting thing to think about.
All right, you're a busy person, and I know you've got a meeting coming up in a minute. So unfortunately, we've come up on time. I guess if people are interested to learn more, there is, as I mentioned at the start, this excellent interview, 2.5 hours, I think, on the Future of Life podcast, which I can definitely recommend. For people who want to learn more, is there any kind of top resource, a book, or papers that people should read if they want to get up to the state of the art and maybe reflect more on whether this is something they'd like to be involved with?
Well, so we actually put together a report, which is available on our website, silverlining.ngo. It's called Ensuring a Safe Climate. And we did that at the request of policymakers in the U.S. because there wasn't a sort of streamlined but comprehensive view of the state of things. And so if you get that report and if you sign up on our website, we're actually releasing the second edition of that report in a few weeks. And it's got beautiful photos and it's designed to be consumable. So there's also a National Academy of Sciences report published in 2015 called Climate Intervention Reflecting Sunlight to Cool Earth. And that one's more scientific. So if you like digesting a bit more technical scientific stuff and it's longer, then that's a good resource too. And they'll be coming out with a follow-on to that report in a few weeks, which I understand is several hundred pages. So that would be a deeper dive. So you can think of us maybe not quite as the Cliff Notes, but as the entry point for that.
Fantastic. Yeah, I haven't read those, but I did really love getting the chance to learn about this week and preparing for the interview. So I can definitely recommend that people go and look into it. It's a very fun and exciting topic, and I guess the fact that I'm not completely sure what I think of it only makes it more interesting because it's a potential for me to really change my mind and form new opinions.
Yeah, and if you're a person that just likes things encapsulated, there's also a TED Talk. I gave a TED Talk about a year and a half ago, which is 12 minutes. So that's another way of entering on the problem space if you're looking for that. And I'm quite interested, particularly in younger people thinking about these questions. They have the most at stake. And there are a lot of old people around the table making decisions right now. So the more, younger people can take a look at this and figure out what they think and figure out ways to vector in, I think that's going to be important for all of us.
My guest today has been Kelly Wanser. Thanks so much for coming on the 80,000 Hours podcast, Kelly.
Thanks very much, Rob. Really enjoyed it.
If you're interested in working on effective ways to mitigate climate change, or one of the other global problems that we regularly discuss on this show, then you can apply to speak with our team one-on-one for free. They can potentially discuss which problems to focus on, look over your plan, introduce you to prospective mentors, and discuss roles that would particularly suit your skills. Just go to 80,000hours.org/speak to learn more about the service and apply if you'd like to. The 80,000 Hours podcast is produced by Kieran Harris. Audio mastering is by Ben Cordell. Full transcripts are available on our site and made by Sophia Davis-Vogel. Thanks for joining. Talk to you again soon.